because otherwise I will say it to the group.
Sounds good. Yeah, I'll,
Yeah.
like 30 seconds, and I'll walk up, and we're good to go.
30 seconds.
Okay. All right, everybody. Why don't we get the last track of the day started? So I would like to welcome our first speaker, Emma. She'll be presenting JAWS, a data warehouse with Spark SQL.
Hi, I'm Emma. I'm a software engineer at Tachyon. I worked mainly on building X Patterns. X Patterns is a big data platform that enables advanced analytics for healthcare, government sectors, and beyond. X Patterns was built 5 years ago, I think. It was built on top of the Hadoop ecosystem, and for the last 2 years, we have migrated it completely to Spark, alongside some other technologies like Cassandra, Mesos, Tachyon, and so on, Solar. Besides Tachyon, I'm involved in building a big data research community. The aim of this community is to provide open source solutions to different use cases and challenges we encounter. This is the agenda for today. There will be a short intro into the JAWS Spark SQL REST service. We will go through the main features and architecture. We will see how it scales and what this involves. We will go through the resource managers that we might use. I will speak a little bit about the benefits JAWS has by working with Tachyon and with data sets stored in Parquet file format. I will show you how to configure and fine-tune the Spark SQL context for this application. And in the end, there will be a short demo to showcase the features and functionality. I will start by imagining the following scenario. Let's say that you have a cluster with limited resources, and you have a team of data scientists, all of them wanting to run interactive queries on top of huge data sets stored on HDFS. So what would these data scientists need? They would need a shared Spark SQL context that will allow them to easily share and efficiently share resources among cluster. But with the ability to run concurrent queries on top of it, with the ability to save the query history in order for them to review it later on. Of course, it would be important to be able to page through huge result set. And what would be really nice is to have a query editor for them to easily craft their SQL queries. So what options do they have? How to make this whole data interactive exploration faster? Well, JAWS is an option, as it is a really easy, understandable, self-contained application that addresses all the requirements stated here. JAWS is a highly scalable and resilient data warehouse explorer. It is a RESTful alternative to the Spark SQL JDBC, but not only, meaning that it has a set of extra features. What's really nice is the fact that it has a UI where you can easily craft queries in order to gain insights from your data and query your data. JAWS has quite a long history. We started working on it since Spark 091. Back then, it ran with Shark. Now it supports Spark SQL, but also has support for Hive queries on top of Hadoop MapReduce. These are the main features JAWS has. You can run queries concurrently and asynchronously. And what's really important is the fact that each query you run, it will be persisted alongside with its results, its logs, and so on. This persistence layer is pluggable. It could either be HDFS or Cassandra for now. You can retrieve, I said that you can retrieve logs. You have two possibilities of retrieving the execution logs, either historically or you have also an API that provides real-time execution logs through WebSockets. A query once triggered, it can be canceled, but this is something that I will speak later on. With JAWS, you have a metadata browser, meaning that you can browse the information about your tables stored in the Hive metastore. But also, you have the ability to manage tables stored, tables registered over Parquet files stored in Tachyon and, of course, on HDFS. There is a configuration file where you can fine-tune the Spark SQL context to fine-tune it and to obtain a better performance. JAWS comes with a built-in UI, which is really easily replaceable. It's an open source UI that was built to showcase all the features inside this REST service. But as I said, it's really easy replaceable. This is the simplified architecture. We are using the SprayCan as a HTTP server. The domain is implemented using the ACA actor system, meaning that each REST API, it is backed up by an ACA actor that gets the job done. Behind, JAWS launches a single long-running Spark SQL context that will be alive during the entire life cycle of the application and will wait for SQL queries to be run on top of it. As I said before, all the query information and query history will be persisted during Cassandra or on HDFS. I mentioned before that we are retrieving execution logs real-time and historically. To do this, we are registering a logging listener to the Spark SQL context, and through this logging listener, we are obtaining the logs per each query. How does it scale, and why would we scale it? Well, it's pretty easy. You can deploy JAWS on different machines under the same load balancer. And this will assure the high availability of your services. However, the throughput here is not what's important. What's important is the fact that the client application will require some memory, will require the memory in order to return the results to the end user. And this will bring a memory pressure on the client side. But it's easily scalable by just deploying, by just adding multiple resources of JAWS. So we are scaling it to assure the high availability. We don't want to have a single point of failure, and to scale up the throughput, the memory throughput that it is on the client side. However, we have a problem here. As you can see, on each JAWS deployment, a new Spark SQL context will be triggered. And all these SQL contexts will end up by using the same cluster resources. So if you don't think very well how you will manage these resources between deployments, you might end up with one context using the entire cluster and idling the other context because they won't have on what to run. Meaning that if a user will trigger a query and the cluster is 100% used, then the user will have to wait for the job to finish the execution in order for his query to be executed. However, what's important is the fact that these queries are run asynchronous, so the servers will still answer to requests that don't imply spinning jobs on the cluster. Okay, so what do we do in this situation? Because it's clear that it's not enough to deploy it on multiple machines. You also have to manage the resources between these deployments. You have several options. JAWS works fine with either of these three options. So it works fine with Spark in standalone mode. It works fine with Mesos or Yarn. For Mesos, you have two ways of working, either in fine-grained mode or in coarse-grained mode. In Attigio, we are using Mesos in fine-grained mode. We are running JAWS over Mesos in fine-grained mode, and we do this because we needed the feature of dynamic resource allocation before it was implemented in Yarn. It was supported by Yarn. So this is how we end up using Mesos in fine-grained mode. But if you consider using it in Yarn, then I would recommend you to use it in Yarn client mode, as you would want to have the driver on the same machine as the client and on a different machine than the nodes in the cluster. Because you won't want to share the resources between JAWS and, I don't know, maybe you have also Hadoop there apart from the Spark executors. Okay. Let's get back to the image where you are deploying JAWS, multiple JAWS instances under the same load balancer. Here, a problem might arise, and it arises. What happens if a user, let's say, triggers a query execution, and the load balancer will forward the call to the JAWS server number 1. This means that the Spark context from the JAWS server number 1 will be the one triggering the query. But when the user decides to cancel it, he might be in the situation where the load balancer will forward his request to JAWS server number 2. And in this case, one SQL context will be the one triggering the job execution, and the second SQL context will be the one that is notified that it has to cancel it. But it doesn't know what to cancel because he's not responsible for that job. To fix this issue, we made use also of the ACA actor system, meaning that on each JAWS deployment, there is an ACA actor that will handle the cancel request. This ACA actor will know about all the other actors, remote actors that are deployed under the same load balancer. And when this actor will receive a cancel query, then it will broadcast this message to all of the other remote actors. And in this way, we make sure that all the Spark SQL context will be notified that there is a query that must be canceled. And in this way, the Spark SQL context that triggered the query will be the one that will also cancel it. However, there is one thing that you should know here. If you run JAWS with the Mesos in fine-grained mode, the cancel feature is not supported by Mesos in fine-grained mode. So what will happen in this case, the cancel will be made only on JAWS side, meaning that the queries that were in queue, that were supposed to be executed, will be canceled, but the job that it's actually running at that moment on the cluster will continue running, and we are not able to cancel it, but only in Mesos fine-grained mode. One feature we have here, what we have in JAWS is, what, as I said at the beginning, we are persisting the queries with their results. And we are running queries in two ways. You either run queries limited, meaning that we will only save a sample of your data when you only want to have fewer results, or we are running queries with unlimited number of results. For the first case, the sample data from your queries will be saved either in Cassandra or on HDFS. But we know that for most of the users, it's very important to be able to go through and inspect the entire result set. And for this, we are taking the resulted RDD, we are zipping it with index, and write it either on HDFS or on Tachyon. And we are zipping it with index in order to be able to retrieve pages from our results, not to collect the entire result set. As I said before, we are working with Tachyon, and we are using it for two features. We are using it to persist the unlimited number of results, and also we are using it to make the data stored in Parquet files in Tachyon available for querying. We are using Tachyon for several benefits it has. First one is the fact that being an in-memory storage system, it avoids going to disk each time a frequently used data set it's read. So this is very useful, for example, when you have when you have tables that are frequently queried, or when you page through result set, because each time you will ask for the next page, it will be read from memory and not from disk. But This is not the reason why we are using it. The reason why we like Tachyon and why we're using it is because storing the data in RAM memory of heap makes it possible for different applications to share the same resources at a memory speed, meaning that we are able to share the same data sets between JAWS and, let's say, some ETL jobs or maybe some machine learning applications. So this is the actual reason why we are using it. We are registering tables over files stored in Tachyon in Parquet file format. And we are doing this because Parquet file format has a set of benefits. Being a columnar format, it's very good for aggregation queries because only the required columns are read. It supports nested data structures. The fact that the schema is stored alongside with the data makes it possible for the schema evolution feature. And the most important thing is the fact that it supports really efficient compression and encoding schemes as they can be specified per column. So because of these benefits, we decided that we want to manage tables on top of files stored in Parquet file and, as I said, in Tachyon. To do this, we are registering temporary tables over these files. And to make these tables available between and across sessions, we are storing the table information, meta information in Cassandra. If you want to deploy JAWS on-premise, there is a configuration file that you must fill in. It is grouped in the following categories. There is a Cassandra configuration for the case in which you want the persistence layer to be persistence layer to be Cassandra, and here you would have to fill in the ring, the Cassandra ring IPs, to fill in the key space you want to use. On the other hand, if you choose to use HDFS, then you would need to fill in the HDFS configuration part, where you would have to specify the name node, you would have to specify where to store the data, and so on. Also, we have a spray configuration used to to fill in the settings for the spray CAN server. The most large configuration is the application configuration, where every application-related settings are there, like I don't know, the port on which the application deploys, or where are the remote domain actors, or I don't know, there are a lot of them there. And the most important configuration is the one used for configuring the Spark SQL context. Here you can fill in whatever configuration Spark supports. But I won't go through all the possibilities you have here, because it's a vast topic and it might be the subject of another talk. But I think it's important to show you how you will configure the Spark configuration. As I said, you can put here whatever configuration Spark supports. The only different thing is that we are replacing the dots from the configuration keys that are in Spark with dashes. That's the only difference. Here is an example of how you configure JAWS to work on one of the resource managers you have. You will have to set the Spark master either to a Spark standalone deployment or on Mesos or Yarn. If you decide to run on Mesos, then you should specify either to run it on coarse-grained or in fine-grained by setting the Spark Mesos coarse on true or false. If you run in coarse-grained mode, you should specify the maximum number of cores allowed for your application. If you don't specify this, Mesos will assign the entire cluster to JAWS. And the last one, it's for the case you want to run in Yarn mode. You will have to set the Spark executor instances. Okay, so this is how you configure it. This is all that I wanted to say about JAWS. In the next minutes, I have a short demo prepared for you to see how it looks like. Okay. This is the UI that the TJO provides. It's not the open source one. I will show you also that one. Here is the query history. As you can see, queries could be red or green. The red one are the queries that failed. The green one are queries that were succeeded. If you click on one of these queries, you will see the logs and you will see the reason why they failed. In this case, as you see, the query failed because it was canceled. But you also, your query might also fail because of an error, and you will see here the reason why it failed. If you click on a query that was successful, you would see the results. As I said, you have the possibility to browse through the tables stored in Hive. And you have here all the databases. You can search for a database, let's say Movie Lens. You selected all the tables inside that database will be showed. You have the possibility to see what fields you have inside and what type the fields have. Except from the Hive meta store, you also have the Parquet tables registered over files, in this case stored in Tachyon. Here you can also see the fields inside the Parquet schema, actually. In order to register such a table, you will have to browse. As I said, only Tachyon, it's exposed in this UI. You would have to browse the files in Tachyon, and let's say we would like to map this folder to Parquet, to a table. We will give it a name. Okay, and now we should see the table created under the Parquet files meta store. Okay, so it's here, we can see the fields, and we could query it. Let's say we want to run a query, we will go in Hive, we will select a database. Here is the Movie Lens database. Let's say that we would want to see what rating a user gave for a certain movie. So what we could do, let's say we want to where user ID, let's say it's 1 and movie. If you run the query, as you see, I have here a terminate button. This would cancel my query if I want to cancel it. And the results are displayed when the query finishes. Here you have a limited button. Here you can specify whether you want your zipped RDD to be stored on Tachyon or on HDFS. Also, as I said, there is the open source UI, the one that comes with JAWS built in. It looks like this. You still have the query history. You still know if a query failed or not. If it failed, you see the logs, hopefully, if it's still up. Dum -dum. I think it's not up, my UI. Okay, or it's some internet connectivity issue. But all the features that are exposed here are also exposed there, but I think I have a problem with the deployment. Okay, another thing that I wanted to show you is the fact that if we go to Mesos, if you go to Mesos, there is only one Spark SQL context that it's alive, and that it's a long-running SQL context that will live as long as the JAWS application is up and running, and it will expect for queries to be run on top of it. Okay, so that's it. That's all I wanted to show you. If you have any questions, please let me know.
So we have plenty of time for questions. Raise your hands and I'll come with the mic.
Maybe something I didn't get, but my question would be, say, as a user, at least from my perspective, I wouldn't care about Hive, Parquet, Mesos, Yarn, whatever. I just want to do queries on my whole warehouse. So is there like an end user UI that actually does that? Or what's the plans for it? Or did I get it completely wrong?
you can query your entire warehouse. So with JAWS, you have three possibilities. You have the possibility to query the data stored in Hive. That's the first one. And you have the possibility to query data. I get your question. You have the possibility to query data stored in Parquet files on Tachyon and on HDFS. And you probably want to query something that it's in JSON, for example. It's not supported yet. No. Yeah.
Okay, thank you very much. That was a great presentation.
Thank you.
In case we didn't want to use the additional functionalities that you provide with Cassandra, for example, but we want just to have a REST API that gives us an easy access to a shared SQL context, would this be possible with this? Like make a bare bone deployment just REST and a long-lived Yarn SQL context?
If you don't want to use Cassandra, then you have a failover mechanism to HDFS. So the information will be stored on HDFS because you would have HDFS available. But if you want to store these results and the rest of it in another place, the project is open source. You only have to implement one interface, and you will store the data in whatever database you want. But for now, only Cassandra and HDFS are supported as persistence layers.
Thank you.
Welcome.
Hi, thanks for the talk. Actually, two questions for you. One is, so when the results are stored in Cassandra HDFS, are they then TTL at some point? So they are removed after some time, or they still live forever in the storage?
You have the possibility to delete them. They are not deleted automatically, so it's a user trigger.
Okay,
But there is an API exposing the deletion of a query with all its logs, all its results, everything.
Okay, thank you. And second question about the overhead. So in terms of running low latency queries, so for example, we have a server here and then we have SQL context. Is there a lot of overhead from the server to run, let's say, sub-second or sub-10-second queries in SQL, or?
It's the overhead of launching tasks. So if you intend to run queries over data sets that are small, you will have an overhead of launching tasks, and you probably won't want to use Spark SQL for this, because you would have a relational database. If not, you gain performance if your data it's big enough. And also, you also might consider running on Mesos coarse grain mode, for example, where you don't spin each task every time.
Okay, if there's no other questions, why don't we thank the speaker?
Thank you.